corner section of a football stadium has 15 seats in the first row and 40 rows in all. Each successive row has 2 additional seats. How many seats are in the section? So the stadium has 15 seats in the first row. So it means that A1 is equal to 15. And then there are 40 rows in all. So that means that N is equal to 40. Then each successive row has 2 additional seats. So the common difference D is equal to 2. And the question says how many seats are in that section. So he's looking for the sum, Sn. Sn is equal to N over 2 into bracket 2A1 plus to bracket N minus 1 D. So there are 40 rows in all, which is 40 divided by 2 times 2 times A1. A1 is 15 and plus N minus 1. N is 40 minus 1 times D. D is 2. So 40 divided by 2 is 20. Then 2 times 15 is 30 plus 40 minus 1 is 39 times 2. So this is equal to 20 times 30 plus 39 times 2. So 39 times 2 is 78. So this is equal to 20 times 30 plus 78 is 108. And then 20 times 108 is 2,160. So there are 2,160 seats in that section of the football stadium. So let's talk about the geometric sequence, GP. In a geometric sequence, remember we said that the most important thing in a geometric sequence is the common ratio. And you find the common ratio R. It is equal to the last term, which is AN, divided by the last but one term, which is AN minus 1. The general formula for finding the nth term of a geometric sequence is AN equals the first term A1 times the common ratio exponent N minus 1. So this is the general formula for finding the nth term of a geometric sequence. So for example, if we have the sequence 10, 9, 81 over 10, and then 729 over 100, what is the nth term of this sequence? So considering this sequence, find the 9th term and then also find the nth term of the sequence, the nth term of the sequence. So let's find the nth term of the sequence. So we need to find A1. A1 is equal to the first term is 10, so A1 is equal to 10. Let's find the common ratio R. The common ratio R equals the second term minus the second term divided by the first term, which is 9 divided by 10. So the formula for finding the nth term of a geometric sequence AN is equal to A1 times the common ratio exponent N minus 1. So A1 is 10, so 10 times the common ratio, which is 9 over 10, then exponent N minus 1. So we can write this as this is equal to 10 times into bracket 9 over 10 exponent N, then times 9 over 10 exponent minus 1. So since this is exponent minus 1, we can flip this fraction. So this becomes 10 times 10 over 9. All of that times 9 over 10 exponent n. So 10 times 10 is 100. So at the end of the day, this is equal to 100 over 9 times 9 over 10 exponent n. So this is the nth term of that sequence. So the question says that we should find the 9th term. So the 9th term is A9. So what we will do is that wherever we see n in the nth term, we just replace it by 9. So A9 is equal to 100 divided by 9 times 9 divided by 10 exponent 9. So let's go further and simplify. So A9 is equal to 100 divided by 9 times 9 divided by 10. Then I want to write this as exponent 7 times 9 divided by 10 exponent 2. So that you see that 7 plus 2 is 9. So A9 is equal to 100 divided by 9, then times. So 9 squared is 81 divided by 100 squared. 10 squared is 100. Then times into bracket 9 divided by 10 exponent 7. So that this 100 and this 100 can cancel. 81 divided by 9 is 9. So it becomes 9 times into bracket 9 over 10 exponent 7. So A9 is equal to 4.30. So let's talk about the sum of a geometric sequence. The formula Sn for the sum of a geometric sequence is A1, which is the first term, times 1 minus the common ratio r exponent n. All of that divided by 1 minus r. So this is the formula for finding the sum of an arithmetic sequence. This is the formula for finding the sum of a geometric sequence. So let me write it in this form. Sn equals A1 dot 1 minus r exponent n divided by 1 minus r. So let's assume that r becomes so small that it approaches 0. You see that when r becomes so small, r exponent a certain number as the number becomes very big. So when r approaches 0, when r becomes so small that it approaches 0, then 1 minus r exponent n approaches 1. And therefore Sn, which is sum to infinity. So let me change it. Sum to infinity is equal to A1 divided by 1 minus r. So the formula for the infinite sum of a geometric sequence is A1 divided by 1 minus r. So this is the formula for finding the infinite sum or sum to infinity in a geometric sequence. Write 0.999 as an exponential series and show that in the limit, the sum of the limit equals 1. So 0.9999, you can see that this is 4 decimal places. It can be written as 0.9 plus 0.09 plus 0.009 then plus the last one, which is 0.0009. So from here we can see that our first term a1 is equal to 0.9. So what is, and then the common ratio r is equal to the successive term, which is 0.09 divided by 0.9, and r, the common ratio, is equal to 0.1. So the formula for the sum to infinity of a geometric sequence is equal to the first term a1 divided by 1 minus the common ratio r. This is equal to a1 is 0.9 divided by 1 minus r. R is 0.1, and this is equal to 0.9 divided by 1 minus 0.1 is 0.9, and this is equal to 1. So it says a sequence un is defined by u1 equals 2 and un plus 1 equals un minus 1. Find the first 5 terms of the sequence, and then I show that un plus 1 is equal to 3un minus 2un minus 1. Then the B part says that a linear sequence has common difference 3, and the 15th term is 50. Find the first term. So let's find the first 5 terms of the sequence. So the sequence is un plus 1 equals 2un minus 1. So, but the question says u1 is equal to 2. So what is u2? So we see that when we replace n with 1, it becomes 1 plus 1 equals 2u1 minus 1. So that u2 is equal to 2u1 minus 1. And therefore u2 is equal to 2 times u1 is 2 minus 1. And 2 times 2 is 4. 4 minus 1 is equal to 3. So now let's put n equals 2. And that will be 2u as 2 plus 1 equals 2u2 minus 1. So u2 plus 1 is 3 equals 2u2 minus 1. So u3 is equal to 2 times u2. u2 is 3 minus 1. 3 times 2 times 3 is 6 minus 1 will be 5. Then let's put n equals 3. So it comes u of 3 plus 1 equals 2u of 3 minus 1. So u4 is equal to 2u3 minus 1. And this is equal to 2 times u3. u3 is 5 minus 1. 2 times 5 is equal to 10. 10 minus 1 is 9. Let's put n equals 4. So n equals 4. 4 plus 1 equals 2u4 minus 1. So u5 is equal to 2u4 minus 1. And then u4 is 9. So this is equal to 2 times 9 minus 1. And that is equal to 17. So the first 5 terms are 2, and then 3, and then this one is 5, and then we also have 9, and then the last one, which is 17. Then the next part of the question says we should show that un plus 1 equals 3un minus 1. Un plus 1 equals 2un minus 1. So this n plus 1, let's replace n with n minus 1. So it becomes u into bracket n minus 1 plus 1 equals 2 times u into bracket n minus 1 minus 1. So that this part becomes minus 1 plus 1 is 0. So un is equal to 2un minus 1 minus 1. So let's label the equation that we're given in the original question as equation 1 and label what we got here as equation 2. So let's subtract equation 2 from equation 1. So equation 1 minus equation 2, it becomes un plus 1, which is this, minus un equals 2un, then minus 2un minus 1. Then minus 1 minus minus 1 becomes 0. Let's group like terms. We can bring minus un here, and then we'll be left with un plus 1. So un plus 1 is equal to 2un plus un minus 2un minus 1. So un plus 1 is equal to 2un, which is this, plus un from here, minus 2un minus 1. So un plus 1 is equal to 2un plus un is 3un minus 2un minus 1. And that was exactly what we are asked to prove in the question. Now, the last part is a linear sequence has a common difference of 3, and the 15th term is 50. Find the first term. So let me squeeze the answer of that here. So let's find A15. A15 is the same as A1 plus 14D. And he says that 15th term is 50. It implies that A1 plus 14D is equal to 50. However, from the question, it says that common difference D is 3. So D is equal to 3. So we are supposed to find A1, which is the first term. So the question says we should find the first term. So A1 plus 14 times D, which is 3, is equal to 50. So A1 is equal to 50 minus 14 times 3, which is 42. And therefore A1 is equal to 8. Find the number of terms of the arithmetic sequence 4 plus 6.5 plus 9 plus 11.5 needed to make a total of 126. So the sequence is 4 plus 6.5 plus 9 plus 11.5. So what is the first term? A1 is equal to 4. And then it says that to make a total of what? 126. So that means the sum Sn is equal to 126. Then the common difference D is equal to the second term, which is 6.5 minus 4. And 6.5 minus 4 is equal to 2.5, and which is equal to 5 divided by 2. So let's write the formula for the sum. Sn is equal to n over 2 into bracket 2a1, then plus into bracket n minus 1d. So we know the value of Sn. Sn is 126, which is equal to n, which is what we are looking for. So n divided by 2 times a1. a1 is 4, then plus into bracket n minus 1 d. d is 5 over 2, so times 5 divided by 2. So let's multiply through by 2. So this side by 2 and this side by 2. So that this 2 and this 2 can cancel. 2 times 126 is 252 equals n times, so let me use curly brackets. 2 times 4 is 8 plus n minus 1 times 5 divided by 2. So let's go ahead and expand by multiplying through by 5 over 2. So 252 is equal to n into bracket 8 plus 5 over 2n minus 5 over 2. And therefore this becomes 11 over 2 plus 5 over 2n. So in multiplying through by n, you see that 252 is equal to 11 times over 2 times n will give us 11 over 2n. Then plus 5 over 2n times n becomes 5 over 2n squared. So let's multiply through by 2. So 2 times 252 is equal to 504. So this is 504 equals 11n plus 5n squared. So let's bring 504 to this side of the equation. So we get 5n squared plus 11n minus 504 is equal to 0. We don't know the factor. So one thing we can do is, this is of the form ax squared plus bx plus c is equal to 0. A is equal to the coefficient of n squared, that's 5, and b is equal to the coefficient of n, and that's 11, and c is equal to this term, which is minus 504. So remember that by quadratic formula, x is equal to minus b plus or minus square root of b squared minus 4ac all divided by 2a. So in this case, since we are dealing with n, it becomes n equals minus b. b is 11, so it becomes minus 11 plus or minus square root of b squared, which is 11 squared minus 4 times a times c. A is 5 times c is minus 504. All divided by 2a, which is 2 times 5. So n is equal to minus 11 plus or minus square root of 11 squared. 11 square root of 11 squared minus 4 times 5 times minus 504 is equal to 101. All of that divided by 10. Sorry, I made a mistake here. N is equal to minus 11 plus or minus square root of 11 squared minus 4 times 5 times minus 504 is equal to 101 divided by 2 times 5, which is 10. Terms involved cannot be negative, and therefore this is equal to minus 11 plus 101 divided by 10. And this is equal to 90 divided by 10, which is equal to 9. The third and sixth terms of an exponential sequence are 1 over 4 and 1 over 32 respectively. Find A, the first term and the common ratio, and then B, the eighth term of the sequence. So let's write the formula, the general formula for finding the nth term of an exponential sequence, and that is an equals a1 times the common ratio exponent the number minus 1. So the third and then the sixth term. So let's find a3. a3 is equal to a1 then times r exponent. N is 3 minus 1. 3 minus 1 is 2, so r exponent 2. So this is a3. Then let's find a6. a6 is equal to a1 then times the common ratio r exponent n. N is 6 minus 1. 6 minus 1 is 5. However, the question says that the third term is 1 over 4. This implies that ar squared is equal to 1 over 4. And the sixth term is 1 over 32. The sixth term we got as. So this is a1. a1 r exponent 5 equals 1 over 32, which is 1 over 32. So we need to solve these two equations simultaneously, so that this becomes our equation 1 and this becomes our equation 2. So let's divide equation 2 by equation 1. So this becomes a1r exponent 2 divided by, exponent 5. a1r exponent 5 divided by a1r exponent 2 equals 1 over 32 divided by 1 over 4. So that a1 and a1 can cancel out. R exponent 5 divided by r exponent 2. This we can use indices. It becomes r exponent 5 minus 2 equals 1 over 32. Then this divided by, I'll change it to times, so that I'll write 4 over 1. So that r exponent 5 minus 2 becomes r exponent 3 equals 32 divided by 4 is 8. So this one will equal to 1 over 8. So what we can do is to take cube root on both sides. So the cube root of r cube is r, and this is equal to cube root of 1 is 1 divided by cube root of 8 is 2. So let's put r equals 1 over 2 into, let's say, equation 1 and find the value of a1. So equation 1 is a1r exponent 2 equals 1 over 4. So let's make a1 the subject. It's equal to 1 over 4r exponent 2. So a1 is equal to 1 over 4 times r. R is 1 over 2. 1 over 2 exponent 2. So a1 is equal to 1 divided by 4 times 1 squared is 1 divided by 2 squared is 4. So this 4 and this 4 cancel out, so that a1 is equal to 1 divided by 1, which is equal to 1. So therefore the common ratio r is equal to 1 over 2, and then the first term a1 is equal to 1. Now the question, the B part, is saying we should find the 8th term of the sequence. So let's use this to write a8. a8 is equal to a1, and a1 is 1 times r, the common ratio. And in this case, the common ratio is 1 over 2. Then exponent n. N is 8 minus 1. So a8 is equal to, into brackets, 1 over 2 exponent 7. And 1 over 2 is equal, exponent 7 is equal to 1 divided by 128. The 13th term of an arithmetic progression is 27, and the 7th term is 3 times the second term. Find the first term, and then B, find the common difference, and then C, find the sum of the first 10 terms. The general formula for finding the nth term of an arithmetic sequence: an is equal to a1 plus 2 bracket n minus 1d. So he says that the 13th term is 27. So let's find A13. So A13 is equal to A1, then plus n. N is 13. 13 minus 1 is 12. So 12d. This is A13. However, the question says that A13 is 27. So this implies that A1 plus 12d is equal to 27. So this becomes our equation 1. And then the question also says that the 7th term is 3 times the second term. So let's find the second term, A2. A2 is equal to A1 plus into bracket n. N is 2 minus 1 is 1. 1 times d is d. So A2 is A1 plus d. Then he says that the 7th term, so let's find A7. A7 is equal to A1 plus n. N in this case is 7. 7 minus 1 is 6. So A1 plus 6d. And he says that the 7th term is 3 times the second term. So it means that A7 is equal to 3 times A2. So this implies that we should multiply this A2 by 3 and equate it to A7. So this implies that A1 plus 6d is equal to 3 times A1 plus d. So A1 plus 6d is equal to 3A1. I'm expanding this. 3 times A1 is 3A1 plus 3 times d is plus 3d. A1, I'm taking 3d to this side and bringing A1 to this other side. So 6d minus 3d will give 3d equals 3A1 minus A1 equals 2A1. So 3d is equal to 2A1. However, so this becomes equation 2. However, from equation 1, we know that A1 plus 12d is equal to 27. This is equation 1. So we are looking for 2A1, and therefore let's multiply equation 1 by 2. So 2A1 plus 2 times 12 is 24. D is equal to 2 times 27 is 54. So this becomes equation 3. And therefore we can substitute this equation because it says 2A1 is equal to 3D. So this 2A1 we replace it with 3D. So 3D plus 24D is equal to 54. So 3 plus 24 is 27D equals 54. So we are saying that 27D is equal to 54. So let's divide through by 27. Divide here to by 27. So this and this cancels. At the end of the day, D is equal to 54 divided by 27. And that is 2. So D is equal to 2. So since we know D is equal to 2, from equation 2, we said that 3D is equal to 2A1. So 3 times 2 is equal to 2A1. And therefore A1 is equal to 3 times 2 divided by 2. So this 2 and this 2 can cancel out, so that A1 is equal to 3. So the first term, A1, is equal to 3. The common difference d is equal to 2. Now the question says we should find the sum of the first 10 terms. So let's write the formula for the sum. Sn equals n over 2 into bracket 2a1 then plus into bracket n minus 1 d. So n is 10 divided by 2 equals 2 times a1. We got a1 as 3. So 3 plus into bracket n is 10 minus 1 is 9. Okay, so the better still, let me write it. 10 minus 1 times d is 2. So times 2. 10 divided by 2 is 5 times 2 times 3 is 6 plus 10 minus 1 is 9. 9 times 2 is 18. So this is equal to 5 times 18 plus 6 equals 24. And 24 times 5 equals 120.